Alright, hit the button. Probably I shouldn't have. But anyway, yeah, draft science videos. So many subjects on my mind. In different videos, all this kind of stuff. So I'm just going to let some of this stuff happen, see where I go. Just about stuff I want to talk about. So there's these Dawkins, Krauss video conversations, whatever, debates. I haven't finished this one. Watched a couple. It's sort of challenging as a way of taking in content, to mix these two kinds of subjects, biology and physics. But what it really reveals in some senses, I would argue that there's a big difference between how biology is conducted and how physics is conducted as a science, and that biology relies on much stronger evidence before conclusions are drawn, before people start saying we know something. It's usually because they have a human genome, they have a real roadmap, they have real evidence, where physics relies on interpretation of what could be called circumstances are experiments. Circumstances are in a sense experiments, you could argue. The existence of New York is a kind of experiment. It's a circumstance that we didn't create on purpose, didn't do it on purpose, but it provides information as a mechanism. That's what I'm trying to say. And I would say that physicists, they start saying we know way too fast. And they establish something as a truth or a premise of the science before it's been established as a truth or a viable, rock solid, real, foundational fact. And that's a huge distinction. I'm not saying Dawkins is doing better science, because there's some things he says that are kind of lazy in terms of, well, in these conversations, he kind of states that I want to understate the way he's saying it just to demonstrate that I'm not trying to be prejudiced against what he's saying, but he states kind of, I tend to believe, that there is other life in the universe, and but there's no, he provides no evidence for that belief, in the sense that the only evidence is, gee, there are so many things out there for life to grow on that it must be growing on some of them. And it's not, there's no depth to the conversation in terms of recognizing that the counter argument about the rareness, like he'll concede life is rare chemistry, but there's no description of that rarity in any kind of similar context to the expansiveness of the universe or the size of the universe. And so yeah, I'd say there's an example where Dawkins is essentially supporting a notion, but supporting it with nothing. Just in, gee, it feels like that should be the right answer, kind of a thing, rather than any, there's nothing in his science says that's the correct way to interpret the evidence. There's no, the evidence doesn't scream it in some way. It's not a flat earth, round earth question where, yeah, 100% of the evidence supports one conclusion, 0% of the evidence supports the other. It's not that kind of question. And yet he talks with a lack of specificness, and yet implies something. So, like I said, I don't want to, I appreciate the fact that he's somewhat careful in what he says, but again, in these conversations, he wasn't as careful as I've heard him before, where he just says, look, this isn't science anymore, this is just something I sense, or I feel, or I think. And he didn't do that in these conversations. So anyway, so getting to that, it's, there's just so many subjects. But anyway, so the first thing I guess I would argue, as a way of, okay, what physics is we're back to this apple, the size of the Earth thing. Atom. Okay, so an atom is an atom is to an apple what the Earth is to an apple. Right? Well, I probably said it poorly, but the point is an apple is to an atom what the Earth is to an apple. Still didn't sound right, but I think that was right. So anyway, you're talking about a very huge. So just take the apple Earth thing and just go, okay, that's one level of relative size that you have to appreciate somehow. Somehow you have to conceptually understand how small these things are, in the sense that they're small like apple and then Earth. And then you have to do that a second time to go from the atom to the bits that make up the atom. So you really have to get a sense of just how small the actual mechanism bits are. There are two levels of apple Earth down, which is, you can't get, I mean, that's a big universe. You'd have to concede. That's a huge universe that, you know, in an apple, you have this transition, you know, this comparison of going down smaller, something so small that it would be like an apple to the Earth is this little atom to an apple, and then you have to do that again inside of that atom. That's a really deep universe of small, you know, as that is maybe twice as small as the big universe is to us. It's only one apple difference, where the down is two apples different. I mean, us to a galaxy or something, you know. So anyway, I mean, that's just something that's got to be like, okay, we concede that point that we're, you know, we can't see these things. We're never going to know them in any kind of intimate way. We're just going to know them as masses, and you're never going to play with one of them ever. But anyway, so all right. So I guess I sort of wanted to get to the so there's this whole level of chemistry, you know, of physics that takes place before you can get to even these chemical compounds. So the chemical compounds, though, aren't too complicated. You can kind of just get the atoms sticking to each other based on the position of electrons and that kind of thing. And then you have to get to this chemistry where you go to biology. And there's where there's this huge, gigantic, you know, the amount of distance from a carbon dioxide molecule and a reproducing cell. You can sort of see that that's almost another Earth to apple kind of thing. That's just a huge distance in terms of complexity. Just weigh the number of things that have to happen, the number of pieces that have to be in place. Okay, so I guess I'll do the biology thing. So anyway, you know, Dawkins' implication, just this implication that, you know, there's something systematic about the evolution of physical matter falling into some sort of inevitable patterns. I just think it's presumptuous, just because of the, you know, there's like this infinite arrangement of these elements. So you have these 100 different structures, and you can arrange them in just this infinite way, just like a DNA molecule can have there's an infinite way to code it, almost. I mean, perceptually infinite. Where to go? You know, so anyway, so yeah, so I guess the argument I'm making is not only does once you have a reproducing cell, are you an apple compared to the Earth kind of distance away from a neuron. You know, these are just huge, gigantic levels of complexity, scale differences. And so I guess that's what I'm saying, is sort of being underappreciated. And especially when we have absolutely no clue how bizarre an event has to be to create any one of the steps, in all the steps, the million steps. And we don't know crap about any one of those steps, how bizarre it had to be for it to jump that distance. Every little distance had to be jumped, and some of these distances are, the only way you jump them is with some sort of bizarrely improbable event. So how many bizarrely improbable events can you stack up before you've created a circumstance that's just too ludicrous? Flipping coins, and let's say the flipping of the coin was a note played, or the rolling of dice, and say with each roll of the dice it played a different note based on the number that added up, and that you roll dice and you play Edelweiss or something randomly. I mean, how many times would dice have to be rolled where you finally play Edelweiss? You could imagine that would be a number that could go on forever. And all I do is change one note of the song, and it's 2 times forever. Or I add one more note, and it's 2 times forever. Alright. So I'm just arguing that this is the context of the conversation. So when you're going to start talking about the probability of life, you have to get over this huge thing over what, how life is, how it exists, what makes it exist. And so I guess I just want to talk about some of that, because he didn't go into huge detail, and I just think some of it's sort of important to understand when he says you need this blueprint molecule. Yeah, that's correct. But how do you get there? What does it have to be before it's a blueprint molecule? Because you can't have something that reads CDs before you invent the idea of a CD. The idea of a CD has to exist first before you can invent something that can read one. That kind of thing. So there's a whole bunch of process here, mechanisms that, there's no way for Dawkins to presume a simplicity of that thing being created, because it's almost what is. We can't model it. We can't figure it out. We can't draw a blueprint of this, how it could possibly happen. So how can you presume that it's within a one universe worth of probability, or any kind of probability, that it's anything but a hugely bizarre. It's like the tune was played by the dice before anyone knew what the tune was supposed to be, and so yeah, life happened, but that tune's not going to be played again. And there's nothing, you can argue that you could take life at any stage, fiddle with the genetic code, and then make some sort of different outcome. But you still have to start with something that's well along in the process before you can even do that. Well, let's imagine that it produces some other kind of organism. So the very idea that there might be different ways to create something that replicates, there's not even any evidence that there are different ways to do it. There may only be one way to do it. Alright. Yeah, I wish this was, you have to kind of watch the videos to get to the context of the conversation. And so I just, there's just some of these things I just figure I'll say, for whatever value it has. But I guess I just want to make it clear for people to understand it's not just about the fact that the DNA molecule replicates. Okay, so the idea that you have this molecule, or even RNA or whatever, it doesn't matter. The idea is just that you have a molecule that's basically rungs of the same stuff, and it's held together, by pieces, and that's it. And so what you're basically doing is you just cut the molecule in half. The 2 pieces will reconstruct the other side, because this will have the left shoe, they'll put the right shoe back on. You'll just keep doing that left shoe, right shoe thing. And so that's what the DNA molecule does, is that that's how it replicates, is that it is a molecule, it breaks, and the breaking of the molecule, the splitting of it, the detaching of it, creates the opportunity for this copy to be made. But it doesn't make a copy in some kind of deliberate way. It's only making a copy because it was broken, and because of the way it breaks, it always creates the other side. It always creates it always fills the void created by the break. It always just replaces whatever broke off. And so there's only a certain kind of chemistry that'll do that. We haven't found anything else that can do it besides these protein molecules made of these amino acids. And there can be different arrangements of rungs and rungs versus the bars, or whatever you want to call them. The way the ladder's made, but it's pretty, we can't synthesize it made out of something else. Some sort of molecule that can be split in half and it'll fix the broken half. Okay. The very idea of having a molecule in the first place that has this idea of where it can have a blue here and a red here, and then a red here and a green here, and the idea they can have a system that has these reciprocal, green is always blue, red is always yellow, or whatever the thing would be, where it always has to have this complementary opposite. Isn't that, it's not a simple thing in itself. So just having one, though, is absolutely useless, right? Because you have to have, if you have genetic reproduction, you still have to have some mechanism that splits this thing in half, and then you have to have a mechanism of taking this molecule and somehow making use of it. So say you've made the copy, it floats around, and it doesn't do anything. It doesn't make a human being all on its own. The molecule can't do crap. So there's a whole infrastructure that the molecule has to exist in that somehow can read this molecule and make processes happen based on what it's reading. So it has to interpret the molecule and make chemicals that cause a chain reaction of events. So like at this point, the reader would be going down the molecule, it would read a certain thing, it would shoot a chemical into the space. Over time, it has, the molecule knows, so to speak, that piece of chemistry is floating here, and it knows exactly where it's going to float because it's engineered the whole circumstance. And back down here, it shoots out another piece of chemistry to intersect with this one and create a compound. So it's like it's building things because it's been engineered over billions of years to be able to duplicate an entire circumstance. The entire membrane is everything inside of the cell is essentially a controlled Rube Goldberg kind of. The iron hits the bowling ball, hits the bowling pin, hits, goes around and around, does this thing, and it's reliably built this cascade. That has to be recreated, and it's recreated by just reading it off this DNA molecule. So the original life thing, the original DNA molecule couldn't do this reading thing, so somehow the first DNA molecule has to have something slide against it that creates one piece of chemistry, and then that one piece of chemistry has to somehow tend to eventually create some mechanism that can slide down the whole molecule and create a cascade of chemistry that in some way precipitates this process that would inevitably lead to creating a thing that's reading. But that's the trickiest part, is the reader. The reading chemistry is the trickiest part of this whole argument, is that this is basically the instructions, and the instructions basically have to be read, and they have to be read by crude chemistry. And that's a lot to comprehend. But anyway, so I would argue that the first molecule was had this function, but they all floated around, and they could get longer or shorter. And so it's like DNA molecules only became a set size when they actually put code in that said this is the end of the molecule, because the molecule could go longer. There was nothing stopping it from becoming a longer piece of protein. And so the original pieces were all kinds of different sizes, and they had all kinds of different stuff on them, and errors would be made, and those errors would be a different piece of DNA, and the errors, the ones with certain errors might last longer because they created certain chemistry that created a safer environment for them. So if they created some sort of acid that destroyed, some other chemical compound that might hurt the protein molecule or break it down, so essentially I'm saying is the first molecules, the first chemicals they ended up creating by interacting with, there has to be some associated compound, some associated molecule that hit the DNA, slid across it, and changed its chemistry or produced a new chemical because of the interaction with the DNA molecule. It had to in some way interact with the DNA molecule, somehow change its chemistry where it either burped a chemical or it itself was changed into a chemical. And then that chemical, depending on what it was, an acid for example, would destroy the competing DNA or would in some way create an environment that allowed this DNA molecule that just got read to more likely be reproduced. So here you had evolution in the chemistry of just the DNA molecule long before there was evolution in the biology. So long before it was a blueprint molecule, it was a raw chemical molecule. It just made chemistry. It made compounds. And eventually it had to make the compound that would be capable of producing more than one chemical, one reaction. And so it would be essentially, this would be deciding what the reflex of this other chemical that hit against it, the chemical that was interacting with the DNA molecule, is the one that's really doing the work. So the DNA molecule gets all the credit, but the reading molecule, the molecule that's actually producing chemical reactions to what it's reading, that's the real deal. That's the chemical that maybe somebody should have a name for and give it some sort of notice or recognition. Because without that chemical, you're never going to create an organism. You're never going to create a multicellular or any of this other stuff. So it has to just be understood that this whole environment has to be created, and that essentially part of what has to be created is the membrane that makes this even a more controllable evolution of the molecule. You have to have some way to protect it from the real world. And that's when this is another huge step in evolution. I mean, a hugely complex thing had to happen where this interaction with the DNA molecule created enough of this compound to create some sort of bubble, like it could just be a water droplet, the first membrane, and dirt would be arranged around the sides. But regardless of what it was, it still had to be something that got incorporated, that got preserved. Say that dirt ring got turned into a cement ring by the chemistry the molecule created. So that essentially the molecule would be sitting in here. It would have to have code on it that would tell this reading molecule to produce calcium, and the calcium would float to the edges and stick to the dirt on the bubble, and it would make this membrane more permanent. It could be any kind. I'm just using that as everybody kind of understands cement. So I'm just making cement as an example. But it had to make it into something durable, that wouldn't just pop and go away. And now then also when it's getting split, there's another chemical that this thing produces that basically tells this maybe the simpler piece of chemistry that's in the area that might attract it to the DNA molecule to create the idea that molecule has to go down the middle of this DNA molecule and make two pieces. It has to break the rungs of the ladder, make the molecule split apart, fall apart, so it can do the copy. And now the trick is it has to take this membrane with it. So it also has to produce some sort of chemistry that forces this membrane to bisect. So there has to be chemistry that pulls pulls at the membrane and creates the idea that we're going to throw one of these copies in one side and throw one of these copies in the other side to do this splitting thing. And so I'm just saying, so you can sort of, if you start, I'm just making this model not because I'm trying to be patronizing or something. I'm just saying that when you start thinking about all these levels of what had to happen chemically, just to get chemically to a cell that could really treat the DNA molecule as just a blueprint, as just a row of instructions, where first the DNA molecule had to create actual chemistry, and now it just creates instructions. And that's when you get to real evolution. I mean, real biological evolution doesn't really take place until you've turned the DNA molecule into just something that records instructions rather than something that actually does the production of chemistry. And so again, that reading molecule is the one that makes a huge difference. But but the evolution was starting before life started. So I guess that's the other point I wanted to make, is that they never really say that. But the chemical evolution was as big an evolution in a way as the biological, in terms of the number of steps, the number of little things that had to happen in terms of changes and levels of complexity to go from a single piece of protein into a piece of protein that's a blueprint. A huge number of steps to go from that to that. Complex steps for which at any one moment one of those steps could require something preposterously unlikely, like 2 lightning strikes, on the head of a pin within, 10 seconds of each other. So anyway, yeah, I guess that's all I wanted to say about that. I wanted to say more, but I'm just, I just don't think you can have a rational conversation about the abundance of life in Earth based on just merely saying, well, life is rare, but it's not impossible. Because we really don't know how practically possible it is, just because there's so many steps to go from elemental atoms floating around to, human being. I mean, I just find it irritating that people would minimize that process or say that there's anything about the process that's automatic just because you created a mechanism where the survivors win, kind of thing. The modifications that create survivability and enhance survivability, that simple process is enough just by itself to do something routinely. It obviously is why we're here, but there's nothing about that process in and of itself that guarantees the outcome. Outcomes as extraordinarily complex as us, that require such an extraordinary number of stairs to be mastered or jumps to be made. They're just, like I said, some of the jumps could be hugely gigantic gaps that were only jumped by bizarre circumstance. So it's like one of those, like the Galapagos or something. It could be a hugely bizarre circumstance, that gets a turtle to the island, or got an owl there. Not a great flying bird, a bird not really capable of flying great distances. But it gets caught in a storm, gets blown around, makes it to the island, that kind of thing. I mean, you could have an extraordinarily bizarre circumstance that gets an organism from hundreds or thousands of miles away to a different location. And that saga, to just say that is automatically going to happen, clearly it doesn't automatically happen, because there's no bears on the Galapagos. There's no, you can go through all the organisms that never made the voyage and just say, I mean, clearly it's not that easy. Yeah, I'll take a break and come back. Yeah. Um, it's just so much. I mean, they talk about the whole space thing. I don't know why they're obsessed with that kind of notion, this idea that the says that somewhere you could jumpstart this and just say, okay, you could take the RNA or you could take some predecessor in this process of creating this reproducing molecule, that some percentage of a real life thing, besides just molecules, just elements and compounds, that you could have some genuine real piece of an advanced part of pre-evolved chemistry, chemistry already substantially evolved, travels through space and seeds all of space, and so life is therefore more abundant because it has this huge head start of some sort of molecule. And again, a DNA molecule without anything to read it is meaningless. It doesn't have any meaning as a replicating molecule. I mean, it doesn't do anything. Doesn't have a function. Can't be a living thing. Can't evolve, I guess is the point, in any kind of meaningful way. I mean, it's not going to be able to enhance its survivability except by some circumstance where the ones that produce acid might have an opportunity to replicate more than the ones that don't produce acid. But that's it. There's not going to be anything more elaborate than that until you create a piece of chemistry that somehow creates something more complicated than just acid. It can't just be a piece of something bouncing off of it, going in as carbon monoxide, leaving as carbon dioxide. It's obviously got to be something more complicated for the rungs on the DNA molecule to mean something, which means that basically the molecule has to read the molecule. It has to be changed by by interacting for a longer time with the molecule. And sort of some of this makes sense because it's like when they had the big arsenic fraud, where they created an arsenic DNA molecule, they claimed. That was sort of the interesting part, is that the arsenic wasn't part of the DNA molecule, it was sticking to the DNA molecule, and sort of indicating that that's something about this DNA molecule, is that it does attract chemistry, and that that its surface isn't just what the DNA molecule is made out of. It's not necessarily a clean molecule. It has other compounds stuck to it besides the actual DNA molecule. So it's like a sticky molecule, which is kind of what I'm arguing is essential to this whole process, because you have to be able to make complex chemistry right on the surface of the DNA molecule. The DNA molecule essentially had to create some of the compounds, or maybe all of them, that end up being part of the mechanism that turns it into a blueprint. I guess that's what I'm trying to say. I think that was the important point here. And that process in itself, just that one little process, in my opinion, deserves to be appreciated as being probably more complex than all of the evolution that took place in the last 500 million years. Yeah. All right, anyway. Yeah, I'll be back. All right, now to the Lawrence Krauss kind of bit. So he's promoting his book, The Universe from Nothing. And he has this title that's, all over the place. And the theory is completely unsatisfying. There's nothing. His argument basically is, well, nothing isn't really nothing. And this whole cosmological argument of space expanding is, again, so it's based on what kind of evidence and what interpretation of evidence. And then once they have that interpretation, I would argue that now they've created two synthetic things: dark matter inside a galaxy, and now dark energy outside a galaxy. And so now 40 times the mass of the universe is somehow not really mass, except it's gravitationally significant because it creates lensing, and redshift or something. But I mean, first they make things more gravitational by creating dark matter, and they still don't have enough to justify the universe staying together. So then they create dark energy to push it together. So this is something he commonly says, gravity sucks, and he points out how that's how they're all taught, the physicists, that gravity pulls. It's a pulling force. And I'd argue they really don't have any evidence to draw that conclusion. They haven't even defined the force. The force, Einstein's description of it is just to create a synthetic place to create the force, this synthetic idea of I'm going to use gravity to explain gravity. And so he pulls space down and uses gravity to push things in the hole he made. And everybody's called this an explanation. This explains gravity. It demonstrates gravity. It doesn't explain gravity. It's a demonstration of gravity working. But and it's just this artificial place he's pulled, this space-time. Everybody uses this term, space-time, space-time. Time and space are both nothing. You can't bend them. You can't pull them down. You certainly can't do it in 3 dimensions rationally. But what you can understand logically is that there has to be a convergence. That there has to be some reason that this thing, the sun, is somehow making this thing go this way. So that's what they know. They can say, yeah, we know that much. We know the sun isn't moving into the earth. We know the earth is moving into the sun. And something must be giving the earth velocity. It's accelerating, like it's falling down in an elevator. It's doing things that we know to be, but see, the elevators are again using gravity. It's doing what something's doing when you shoot something out of a gun. It's moving from the place here, and then somehow it's going there, and like a bullet. So they know that part. So that part's correct. And so you can do 2 things. You can say, well, why is it going from here to here? Is something pulling on it with a rope or something, and just saying, okay, let's pull it towards us, or is something pushing it? So that's what your choices are: the suck or the push, or the pull or the push. I would argue they chose the wrong one. They decided, let's go with this suck idea. Let's go with this pulling idea, because they couldn't imagine a cause either way. They can't come up with what the pull is. They couldn't come up with the push is. So they just decided to choose one essentially, and then they're glued to it. And I would argue it's obviously the wrong choice. It seems kind of intuitive to me that you would say, well, look at this thing. It's a closed system. Where would if I'm going to say there's something that's going to be causing it, and we know that the something sort of can't be the things themselves, because the things themselves have no magic energy anywhere. They can't just, the earth can't burn itself as fuel to move into the sun. The earth doesn't lose anything. Okay, it doesn't shrink, doesn't shrivel, it doesn't do anything when it's moving into the sun. So there's something, somehow this is free energy. Well, they know it's not free. And like I said, Einstein just created a fake place to make the energy. He created a fake bent space that uses gravity as the energy source. That, bogus. So I'm just saying, as a crude way to look at it, you could say, well, the stuff is in here. We know the sun's not burning anything, beyond the photons it's producing. It's actually producing a get the fuck away from me force. It's throwing a bunch of energy out, saying don't come anywhere near me. So how do you account for, and we know it's doing that by this huge, the little tiny bit of force it's creating with these photons. We know it's doing that with this huge nuclear engine burning, whatever, 40 million tons of whatever per second. So we know it's not the source anyway of some pulling. The sun doesn't shrink as it pulls on more planets. It doesn't obviously expel anything to indicate it's using energy. It's converting. And again, the Earth isn't demonstrating it. So obviously the conclusion would be, well, it really can't be something inside of this circumstance. It really has to be something outside the circumstance that's doing it. And somebody 350 years ago or whatever did what I just did here. He just drew this obvious conclusion. He said it's kind of a closed thing. How do you even make a pull? What do I make that out of? How would I even make the rope, and then how would I make the thing that pulls the rope in? How would I make this? And how would it work? In all the other circumstances you have to make it work in. Well, anyway, so, they did the obvious thing. They tried to come up with some way to make an external force, a force of discrete, ultra-mundane bits of energy. But their problem was they didn't understand nuclear physics. They didn't really understand environments that don't have any friction in them, environments where you could hit something with an indestructible bullet, and that in a sense, the bullet wouldn't have a residue, a decrease in its speed, that you could bounce something off of something and it would leave exactly with the same energy it went into the interaction with, and all that would change is the direction of the things. So they really didn't understand a purely kinetic interaction, because there's nothing in our real world that's purely kinetic, because everything's covered in atmosphere and surface gravity friction, the friction caused by gravity. So we're in such a dirty environment. They didn't have like space where they could throw two things at each other and watch them bounce off of each other without any friction. It just didn't exist. So they couldn't metaphor it. They couldn't draw the model of it. And so they created systems that always created things like heat and all that kind of stuff, where if you make everything out of this stuff and understand a purely kinetic reaction where there's nothing extra falls off and the interactions are complete, conservative, and the only thing changed is direction of the things interacting, then as I'm pointing out, you can make it work. So you can make their idea work. You just have to understand that you can't think of it as throwing rocks at other rocks, because they're not going to behave frictionless and purely kinetic, especially on planet Earth. All right. So yeah, I don't know. I don't really need to go into depth on that. Somehow that's I've gone far afield of the argument of what gravity is and how it can be understood, and how you just can't keep creating these artificial mechanisms, so now they're using multiverses and extra dimensions to do exactly the same thing they did with Einstein's spent space. They're just finding a fake place for energy to pop in and pop out of existence. So this Krauss guy builds this whole nothing theory on ideas like, inside of neutrons right now, virtual particles are popping in and out of existence. It's a virtual particle, which means it isn't really real, right? So how can it do anything real? And if you're going to say it can do something real, then it's not virtual. And fundamentally, you're just destroying the whole conservation principle by saying something can pop in and out of existence. But again, that's what they're doing. They're creating a mechanism where when it's convenient, it has more energy. When too much energy is inconvenient, we'll just extract it and put it in the other dimension. But all of these are just artificial blobs of bullshit. Dark matter, dark energy, dark blah blah. They're just contrivances to make their wrong interpretations work. And somebody should call bullshit. This isn't very good science. I mean, somebody should be able to say it's not very good science besides just me. This is pitiful science, to say that we know something when all they've done is create something that doesn't even answer the question. Sounds like religion. I mean, you have a circumstance, we exist, you have all kinds of ignorance, and you sit there in that field of ignorance and just start making crap up. Well, the stars have an arrangement, and how they're arranged when you're born affects who you're going to be, and blah, blah. Just make up shit. And it's just made up. Make up connections that don't exist.
I was going to say...
So this is the part where Dawkins asks Krauss a question, a leading question maybe. But yeah, it's good that he doesn't say it as I would say it, which is, gee, I can explain biology, but you physicists don't seem to explain anything. You just basically tell me I'm supposed to believe space is expanding. I'm supposed to believe. Well, I'll let him say it, but I mean, obviously, I would say it a little harsher.
I think one of the things that I worry about physics is that it's so utterly counterintuitive, so totally weird. And I kind of reconcile to this. I kind of reconcile to the fact that my brain, and indeed everybody else's brain, is a product of Darwinian natural selection, designed to understand how to catch prey, how to find water holes, how to make tools, how to avoid being eaten.
All right. Well, this was sort of excessive. That we're designed to be logical, and there's no logical model in physics. There's pretty much just God exists, and then if you ask the question, well, how did God get there? No answer. So they'll just tell you dark matter exists. Where did it come from? What's it made out of? Well, it's not really matter. It's matter unmattery.
By lions. In other words, how to survive in a world of medium-sized objects moving at medium speeds. So our brains were never equipped to deal with things that move near the speed of light.
Well, see, I would just argue that obviously our brain is, because chemistry is much smaller than us. We never even see atoms, but we do understand their relationship to each other, and we can draw a picture of it and a model of it that's a reasonable model. There's nothing reasonable, in my opinion, with the models created by physics. They're first not even true to the circumstance. Again, Einstein's bent space has nothing to do with the 3 dimensions of real space. You can't dimple 3-dimensional space. You have to somehow contract it from all directions, and it's just not a good metaphor. It's not a good model. It's not an accurate model.
And we're never equipped to deal with very, very small things like quanta. Am I popping? Is that just okay? So, in a way, that's one way of saying why physics appears so weird. But I want to ask a physicist, when you have to deal with these weird things like quantum entanglement and the 2-slit experiment and things.
Right. So I like that you brought up the 2-slit experiment, just because we know they don't deal with those, right? So I'm supposed to trust them when they tell me I have an experiment that demonstrates the existence of dark energy, or I have an experiment that demonstrates the existence of dark matter. Well, they won't say that because they don't have an experiment that demonstrates it. But anyway, when they say that, they're saying it based on the veracity of all the other things they're saying it based on, right? And we see how they portray the 2-slit experiment. It has nothing to do with 2 slits. It has nothing really to do with wave interference, because you don't need the 2 slits to create the pattern. Again, you just need the slit. You just need a surface. That's the real thing. The real mechanism is just surface. All you need is a surface to create pattern. One surface will do it. You creating diffraction is what you're creating. And again, this is such a reasonable explanation. And the fact that they so exclusively ignore even touching upon that as a possibility even though those experiments exist. Those experiments exist. The single slit experiment exists. The fact that we don't see the diffraction is clear when you just go against one surface, but you will get light diffracting on a surface. It happens. You only see half of it because the light blurs out the other side of the diffraction. Because there's no other slit. There's no reducing the light source. But you can clearly see as you move a light beam towards a surface that the light is distorted. Clearly.
Do you just say, oh, I don't even try to understand it, or I just get the mathematics right, and the predictions that follow from the mathematics are then tested by experimentalists and they work? Or do you get frustrated? Do you sort of bang your head against the wall because you can't actually understand in your head what it means to say that a particle's in two places at once, or whatever it might be?
Yeah, you can't get a model of it, and yeah, they don't do anything to say it's two places at once, or say there's a multiverse, and so yeah, the particle might be in one place, but it's going to be in a different place in every universe. I mean, the explanations are just bizarrely not good enough for the evidence, and there's no picture of any of this stuff. There's no diagram of it. But again, I'll be explicit. The math is often correct. Einstein's math describing the strength, okay, of the convergence, of the fact that things will move into something because of gravity, okay, that there is a mechanism here where if I put something here, it's going to move in, okay, and I'm going to argue that it's going to move in because of this local interaction. There's nothing about the Earth itself or the Sun that's creating gravity. It's creating gravity when it's in association with something else. There has to be something for the shadow to be cast on before the shadow is cast. As funny as that sounds, but it has to be induced. But once it is induced, it's a real force. And the real force is the energy in the field that you can't see when it's not doing something, when it's not imbalanced. And it's only these imbalances that reveal energy. When you're being hit from all sides equally, this could be a ton of energy, and if it's not in some way breaking you, if it's all energy that goes through you or bounces clearly off of you, it's irrelevant. The only thing that matters is its balance. It's when it's in balance that you start moving, things start happening to you. And that you can clearly, it's clearly intuitive to understand that balance is the thing that's important. I could have something standing up on the tip of its, on its point, and it could seem improbable that it could stay there. But yeah, if all the forces are balanced, it'll stay there, and all I have to do is just blow on it, just one tiny little change in the balance, and we can see what's really there. There is force there. It's just not being realized until you precipitate it, until you instigate it. Again, the tip of the... We're always stuck with metaphor, analogies, common analogies that are in gravity. And it's better not to use things that are in gravity. But you can understand it in space, that if I put a pen in space, it takes merely the tiniest bit of energy to start it spinning. A tiny imbalance. All right, so now we'll get to his answer. Hopefully I don't run out of time on the camera.
Well, I think it's
I haven't watched this, so I was just going to play this just to see what he makes out of that question. I heard the question, and I just said, well, this ought to be good. Let's hear how he constructs a reasonable answer to the question of why does this seem like bullshit.
Combination in both. Physics is weird and then really weird.
Yeah, right. Great. Says you. Physics is, facts are poorly interpreted and then really made up. So maybe that's a better way to say it. Yeah, badly interpreted facts and totally made up facts.
And because relativity is weird, but you can get your head around it. You can intuitively imagine as Einstein did, in fact, imagine what it'd be like to be sitting on a light wave. That's what we let him.
So a light wave, he doesn't even, he won't even concede anything anymore. But anyway, but again, can you really do that? Can you really imagine sitting on a thing going the speed of light and really imagine that everything coming at you, okay, is now coming at you basically at the speed of light? I mean, everything, something that was 100 miles away, something that was a light year away, well, not even the right way to say it, right? Something that was a light second away, okay, you're moving the speed of light. Better way to say it. Something still 1,000 miles away, so you're two still things, and all of a sudden you move the speed of light towards it. That thing is now coming at you at the speed of light. Right? So if you're riding on a light beam, essentially everything that was stationary in the direction that you're now moving is now moving the speed of light at you. I mean, that's not exactly... and then you have to concede that any light that's already traveling from that thing, you're going to get to that light long before you would have. So you have to concede that in some sense, that light is now going to be moving faster than the speed of light, in the sense that when you combine your two locations, the total speed is going to be faster than the speed of light. The light won't be moving faster than the speed of light, but the total speed, combined your speed and its speed, will be faster than the speed of light. And that you will, in fact, when you encounter that light, be encountering something that will inevitably have to have a frequency much, much higher than the frequency it had. So there will be no looking, there'll be no seeing light anywhere around you. Maybe radio waves might look like light, but nothing that you would think was light will be light anymore. It'll be X-rays, and it'll be cosmic rays, and they're going to burn you to a cinder. I mean, I'm just saying that when they use this pleasant little metaphor that Einstein imagined traveling on a beam of light, I'm just saying I don't think Einstein imagined it in any way realistically, because frankly it occurs to you pretty fast that matter traveling the speed of light is going to be in big fucking trouble. It's going to be incinerated really, really fast by a flashlight.
All of the Duncan experiments that he did were ones where you could imagine and have a physical picture. Ultimately, why light bends in a gravitational field is a really simple. It's an experiment anyone can do to understand that. It's just I don't know if it should I take the time to do that? Or
Yeah.
Okay. Anyone could do the experiment he did once you think about it, which is to be in an elevator in empty space. Okay. And the elevator is just sitting there, and there's two holes in the side of the elevator, and a laser beam goes straight across in a straight line. Now, what Einstein realized, which led him to general relativity, is that if the elevator is suddenly accelerating upward, as all of you have experienced, you feel a force pushing you down to the floor. You feel as if you're being pulled down to the floor.
Yeah, well, we already know that that's not what's happening, so what you feel isn't what's happening. So the first point is in these thought experiments is what you feel has nothing to do with what's actually happening, because you're not going to be able to tell the difference between something pushing you down and something pulling you up. So that's true.
And he realized there's no way to distinguish that from gravity. There's no way to distinguish whether you're accelerating upward in empty space.
Right. So that was one of these simple, I don't know what they call that in Einsteinian rhetoric. There's a word for the lack of difference. It's all the same thing. Acceleration is acceleration. It doesn't matter what's creating it or what's causing it. And that would be, to me, another indication that you have to understand that in every other circumstance where acceleration is created, it's always a push. We don't have any other example of acceleration in the known universe, I don't think, where it's not a push, right? Except for magnetism, which again is the same mechanism in my opinion. But where else? Bullets, basketball, it doesn't matter what I take and whatever I give velocity to, I'm always going to be pushing it. There's no example except for something tied with a rope to something and you pull on it, but there's absolutely no example of anything that freely has velocity through acceleration, where it gets that velocity by anything but a push. Certainly in empty space, there's absolutely no way you can come up with some scenario where I'm going to pull that thing towards me. I'm going to suck space, or I'm going to create a vacuum and it's going to pull the thing in. There's no mechanism you could use except for making a planet and have it fall into the gravity, right? So again, there's no pull anywhere in the universe except gravity. So wouldn't that make you think maybe gravity's like all these other forces, it's a push, it's not a pull?
Or whether you're in a gravity.
I mean all these other sources of acceleration, and that all acceleration is push. There's no such thing as a pull. You have to be hit by something.
Gravitational field. So that led him to general relativity. But the neat thing is he realized immediately.
See, I don't know why that would lead you to general relativity, but whatever. Get to the bend space part, please.
That meant light must bend. Because if you're an elevator that's accelerating upward, like this, the light goes in a straight line, but the floor is approaching the light. So if you're in the elevator, it looks like the light is getting closer to the...
Right. So again, that's the scenario. Somehow you're looking so fast, you can see with such a frame rate that you can see the elevator move and the light move, and you can see the light bend down to hit the floor of the elevator. When we clearly know that's not what happened. The light didn't bend to hit the floor of the elevator. That clearly the light went straight across and the bottom of the elevator hit it. So why is this okay to say, well, because I can draw it wrong, I can draw the light bending and pretend the elevator didn't move, so I draw it wrong, and I say now light bends because I drew it wrong. But you have to draw it wrong for that to happen. Clearly. Light's the constant. Einstein admits light's the constant, and yet he breaks the constant and now makes the light move instead of making the elevator moving. If you just make the elevator move, the light does exactly what it normally does, which is go straight across. So why is this an explanation? It doesn't explain anything. It's a contrivance. You've drawn the elevator wrong. You've broken the constant that is light to make it bend to the bottom of the elevator. It's a dishonest drawing.
Floor. If you're in the frame of the elevator, because the light starts here, but by the time the light reaches the other end, the elevator has moved up. So in the elevator, it looks like the light is bending. Therefore, he said, if acceleration is like gravity, light must bend.
Right. But of course, you can't perceive it that way. So again, the argument would be as you're moving, you're even perceiving less well. You're receiving even fewer frame rates. So there's no way